Okay, we're going to continue with our introduction to programming. Last time we did Hello World, the program with 4 different programming languages. I'm now going to tie it in with all of the Linux commands we've been working with. So for each one of these programming languages, I'm going to show you how to get the command line arguments. Okay, and this I'm also going to show you how to execute the programs that you make as if they were Linux commands. Okay. So this is a little bit advanced, but it's very useful to know how to do this for yourself. Okay, so let's go ahead. We've got these files on my desktop that I've been using. I'm going to open a terminal, change the directories to my desktop, ls. There's my files. Okay, I'm going to use the Atom editor and open it in the dot directory, which means this current directory. Okay, here's the notes we've been taking. And so now we're going to get command line arguments with 5 programming languages. Okay, so we're going to add a new one in there, Rust. Rust is like C is a very, very old programming language, and Rust is kind of like a newer version of C that doesn't have so many pitfalls. So it would be a really good language for you to learn in your spare time. But again, after this session, we're just going to be talking about Python. So we're going to do one of these in Python 3, and then we're going to do it in JavaScript, and then we're going to do it in Bash. And then we're going to do it in C, and then we're going to do it in Rust. Alright, so let's start with our Python script. Okay, this is just hello. This is Hello World. This is the simplest version of a Python program as you can get, just about. So what we're going to do is we're going to import additional functionality into our program. Okay, so sys is a library. You can think of it as a set of tools. Sys has additional options, like print is a function that's built into Python. Sys has additional functions that you can use. The reason you have to import them is because if they were installed in every single program, every program would be very, very large in size, and we want our programs to be as small as possible. We want to conserve space. Okay, so we import the tools only when we need them. All right. So we're going to leave Hello World alone, and then we're going to print out the argument list. Okay, so the arguments are going to be what gets applied to our program after we type the program name. Okay, so let's get our arguments. So sys.argv gives us a collection or a list of our arguments. Okay, and I'm just storing that in another variable called args. Alright, for args, for each argument, arg, not plural, in args, I'm going to print out. Now notice the indentation here. I'm indenting one line. This for loop is going to run over and over and over again for each argument in the list of args. Okay, anything that's indented under this for loop is going to execute one time for each argument in that list. So what I want to do is I want to print out a couple spaces and then print out the argument. Okay, and this is basically what we're going to do in all of the programming languages, but you see how simple it is here, and technically we don't even really need this line. We can say for arg in sys.argv, just like that, and save a line there. So with Python, this is very few lines of code. You know, if we didn't have this print statement here, we could literally list out the arguments in 2 lines of code. Alright, and you'll see the difference in other programming languages. Okay, so let's go back to our desktop, and remember, to run a program, we use the Python 3 command and then the name of our program. Alright, so the name of our program is helloworld.py. Now I can add additional arguments here. If I don't add any, the first item in sys.argv is just the name of the program that you're running. Okay, so the name of the program is hello-world.py. That's what I typed in here. Whatever I typed in here is going to be the first argument. And I can say 1. Okay, so for each one of these items, arg, let me resize this a little bit. So the first time, this is our first argument, right? And then this is technically the program name, but it's included in case we need it in sys.argv. And then this is actually our first argument, okay? But this is the first item in our list. So each time in this loop, this variable becomes one of the items in this list. This list consists of everything in here. Now we see the first time through the list arg is the name of the program, and we print out 2 spaces. It's string data, and then we add that one particular argument. So over here is our 2 spaces, and then the argument that was stored in there, which was string data as well. So we're adding 2 space characters of string data to the argument, the first argument in our list of sys.argv. Argv stands for argument vector. Vector, basically, you can think of as a list. It's a list of items. Okay. So each time through this loop, argument becomes one of these items. Okay, so the first time through the loop, it's this first item, and then the loop is finished. There's nothing else in the for loop. So it goes back to the top, and it says, are there any more arguments? Are there any more items in this list? Yes, there's another one. And it grabs this one. Now, the variable arg is equal to this string data. So I can print out 2 space characters and then print out that string data. And that's where we get 2 space characters and then that string data. Now the for loop is over, and it goes back to the top. It says, are there any more items in this list? If so, set that item equal to arg. So now arg holds that item, and we print out again, and it just keeps doing that. And then notice also here, when we put quotes around it, this whole thing is just one item in our list. Okay, so it collects the command line arguments just like a normal Linux system, a normal Linux command. If you put quotes around something, then you can have spaces in it, and it counts as just one argument. Okay, so this is a very simple Python program to print out the arguments. Now I'm going to go over the other programming languages a little bit more quickly because we are focusing on Python, but I do want you to see how you do it in other languages. Okay, so this is hello world in JavaScript. Okay, so to print something to standard out, we use console.log. It automatically prints a new line every time you use console.log. And I can say make a for loop for var I equals 0 while I is less than process.argv. So we see this common name here, argv, and we also see in common we're using a for loop. Okay, so we're looking for patterns between the languages here. So we start out a variable I equal to 0. As long as I is less than the length of this list of items, then we're going to add 1 to I each time. Okay, console.log. We're going to add 2 spaces, and then we're going to add to it so this is our list of items, and we need to reference one of the items in the list. Okay, how do we do that? The list items have an index. Okay, so the index starts at 0. Remember, I've said that counting in computer science always starts at 0. So I is our index. We're going to start it at 0. This for loop will run as long as this is the condition in which, if this is true, the for loop runs. Okay, so if I, which is 0, starting out, if that's less than the length of our arguments list, then we run the loop, and at the end of the loop, I++ means I add 1 to I. And so I will be 2, or it starts out at 0, I will be 1 the next time through the loop. And then the next time through the loop, I will be 2, and then it will be 3, and then it will be 4. So each time through the loop, I increments. This is called incrementing a variable. This is the increment operator. Okay? So let's go through here and try this with JavaScript. Oh, we need a semicolon there and a semicolon there. Okay, so in JavaScript you need semicolons after each line. Alright, so let's run node hello world.js 1, 2, 3, 4. Okay, arguments. Now, there's a couple of them here. It gives us the path to node as well in JavaScript, and then it gives us the complete path to this file that I'm running. So it does both. And then it starts executing 1, 2, and then again we see, because of the quotes, it prints out 3, 4. Alright, so that's JavaScript. Let's open up Bash. Okay, so we're going to do the exact same thing with Bash. We're going to look at, I'm going to print out arguments. Oops. For, now we're seeing a for loop again for arg in Okay, so we have a for loop. It's a little different. We're not using the index, right? In Python, let's switch back to Python real quick. We didn't use the index. Arg just became each of the items in the list. Okay. In JavaScript, however, we used an index. And I started at 0, and we used the index to reference each of the items in the list. Okay, both of these are common in different programming languages. Okay. In this case, in Bash, this variable arg becomes each of the items in this list. This $@ symbol is just a shortcut for all of the items provided to you on the command line. So arg becomes each one of the arguments from the command line, and then we print out echo, 2 spaces, and then the argument. Alright, so to run that, we run bash hello world.sh, and we provide some arguments. Alright, now let's do C. Now you'll notice that C is quite a bit more complicated. Alright, already just the hello world part, like in Python and JavaScript, it's basically one line, but there's more to it in C. Alright, so you have this main function, and that's what gets run when you execute the binary. Okay, this is a function that we're defining here, and the function has arguments. In C, you have to give every variable a type. So this is an integer, argc, so that stands for arg count. That's the number of arguments in our list of command line arguments. Okay, and then we have an array of characters. All right, and so what we're going to do print out arguments, and then we have to print out the new line in C, semicolon. Now you see, we keep seeing this for loop show up. Int I equals 0 while I is less than argc. So argc is our argument count. So we get this number just from C does that for us automatically. It gives us the count of the arguments. Alright, argc, and then we add 1 to I each time through the loop. First time through the loop I is 0, second time it's 1, third time it's 2. Okay. And then the loop is defined by these curly brackets. Everything that gets executed. So the loop runs over and over and over again until this condition is false. So as soon as I gets big enough, say we have 3 arguments or 4 arguments, if we have 4 arguments here, as soon as I equals 4, 4 is not less than 4. It's equal to 4. So this would be false, and then we'd break out of the loop and continue with any code down here. Alright, so now we do printf, and we need 2 spaces, and then print. These 2 characters are going to print the next argument in this function. Okay, so I want argv. Argv is our list. Oh, I didn't define that. Sorry about that. Star argv. So this is our array of items from the command line. It's an array, and we say argv. We want the item at index I. Okay, so this item, whatever is stored at index I, gets placed here in the string. So you can see C is a little bit more tricky to use. You have to understand quite a bit to just do very basic things. Okay, but it is a very, very powerful and stable programming language. Okay, Python's a little easier, which is why we're going to start out with that. All right, so this should be good. And we're going to use GCC and compile the source code. C is just a text file, the .c file. We need to make it a binary file. So we need to output a binary file here. So we're going to call that hello world.c.bin. And this is the file that's executable. Okay. No errors in the compiler, so that means it should work. We'll see. And then 1, 2, 3. One, 2, 3, 4. Oh, I forgot a new line here. This will print the new line character. Alright, so I have to compile it again. So we run GCC again. And there we go. So we're getting the same output for all of these. So there are some very common paradigms between all of these programming languages. Alright, and let's do one more programming language. This is going to be Rust. As I said before, Rust is kind of like a newer version of C. It's very low level and very fast language, but it's got some memory management issues that things are a little bit easier to deal with in Rust than in C. Alright, so let's make Rust. And so in Rust, this is just like in Python, we had to import a file, and in C we had the include is how you import a library. Right? In Rust, we're saying use. We need to use a library, and we're going to use from the standard set of tools. We're going to use the environment library, and then Comments are for humans. And then we make a function. Okay, now notice the curly brackets. In a lot of programming languages, curly brackets denote a code block. Okay, so we're creating a function, and when this function runs, everything inside of the curly brackets gets executed. In Python, there are no curly brackets. Instead, you just indent the code. Anything that's indented is considered part of that code block, that section of code. Alright, so back to Rust here, we're going to create a variable args, and we're going to say that is a vector. So remember, vectors are like a list. And what type of data is in the vector? String data, okay, because it's a list of string data that we get from the command line. And then we'll set that equal to the environment library, and we need to use the args function in the environment library and then collect them. And you need a semicolon in Rust. Print line. We need to do our print line hello world first. Then we do down here the print line arguments. For arg in args. Alright, so arg becomes each of the items. We define this variable args that has a list in it. Okay, then arg becomes each of the items in that list. And then we have a print line, and this is just like the C program where %s, that becomes whatever this first item is. Alright, in Rust you use angle brackets, or curly braces. And then the argument gets put in there in that string. Okay, so just like in C, we have to compile a Rust program. In Python and Java and Bash, we did not have to compile anything. They're closer to interpreted languages. Okay, there's a compilation step here for Rust, so we use the command rustc to compile a Rust program. We're going to compile rust.rs. .rs is the extension for a Rust source code file. And we're going to say this is going to be, we have to pick the output file, so we use the -o option. And then we say this is hello world.rs.bin. We're going to call it bin because it's a binary file. Use environment. Oop, forgot a semicolon here. Okay, so it complained, the compiler complained. And there we go. So we see it showed up here. And now we can run hello world.rs.binary. 1, 2, 3, 4. Okay, so that's 5 different programming languages, how to get the command line arguments. Now, why is this useful? It's because you can write your own Linux commands. Alright, and we're going to go into that real quick, how we can do that. So first, we're going to recap how to move files over the CS account. Alright, so I've got all these files up here that I need to move over to my CS account. Alright, so you'll open FileZilla or some other FTP program. This is GFTP. It transfers files. Okay. So basically you enter in your host, cs.indstate.edu, your username, you type in your password. and then it connects. Okay, so this connects to just my home directory. It's the same as if I SSH into CS151.0.0. That's my student account version at cs.indstate.edu. Type in your password. And if I type ls-al, let me see, we have this stuff in here, and if I look back, it's the same stuff. .ssh right there, desktop labs, in these files. Okay, so what I want to do is I need to move these files over. So in my FTP client, the right window is generally my local computer, or I'm sorry, the left window is my local computer, and the right window is my remote computer that I connected to. Alright, so this is the CS server, and on the left here is my computer. Alright, so I want to go to my desktop, and I want to select all the source code files. There's the C file, JS, PY, RS, and bash. So I've got 5 Hello World programs here, and I'm just going to move them to my home directory. Okay, so we see they showed up there. Now down here, if I type ls-al, we see they've showed up there. Alright, so we know that the copy command is just a C program. Okay, so where is it located? We can use the which command to find out where it's located. It's in user/bin, okay, that directory. There is a built-in variable on the environment of Linux called path. These are all the directories. When you type a command on the command line, it looks in every one of these directories to see if there's a program named that. If there is a program named that in any of these directories, it runs that program. Okay, so here we've got user/bin. So right here, user/bin. So it checks this directory first, doesn't find it, it'll check this one, and then it found CP in this directory. So it knows, so I don't have to execute the entire path to the program. I can go /bin, /user/bin/cp, and then I can copy a file. So let's copy helloworld.py to helloworld.py, helloworld2.py. Okay, so this is just the long version. It's the path to one of these files. It's a binary file. ls-al, and sure enough, we've got hello world 2 here. Okay, I can remove hello world 2, but I could also look and see where the remove command is located. It's in user/bin as well. So I could say /user/bin/remove hello world2.py ls-al. Okay, so it's gone. So the point is, if you change your path variable, you can put any of your files, any of your code that you write, you can put that in a folder that's in your path, and you can execute those programs anywhere on the file system. So you can write your own tools. It's very, very handy and powerful to be able to do that. So let's make a directory for our programs. We're going to call it bin. That's standard in Linux. When we look at the path, echo path, we see all of these /bin, /bin, /bin. That means binary. It means basically programs that you've written. So /bin, we're going to make a bin folder in our home directory. Okay, but now we have to add that to our path. Okay, there's all these other directories in our path. We need to add this to our path. Okay, so this is where it gets a little tricky. We have changed our shell to Z shell, and there's a file in here called .zsh. The dot makes it hidden. ZSH stands for Z shell, and RC stands for run command. Every time you log into the system, this script, this Z shell script, executes. Okay, so if I look at that in nano .zshrc, last time we added this command. Every time I log in, it says hello user. Let's just add a little feel good so we feel good every time we log in. There you go. Hello user, you are amazing. Now we're going to add our bin directory to our path. So we're going to change the value of our path variable to be whatever path was before, and then you separate each of the items in the path variable with a colon, and we're going to add our new directory. So our new directory is a bin folder, but it's in our home directory, home/bin. So now anything in this bin directory can now be executed as if it was just a regular command, and I can execute it from any place in the command line, any working directory I'm in. So if my terminal, if I've changed directories anywhere on the system, I can still run this command. Okay, so we're gonna save that, and let's move all of these files. So anything named hello world star, any of those, we're going to move all of those to the bin directory we just created. So the star means if it starts with hello world, and then the star means anything else after it. So that's hello world.c.js, anything else. So it has moved all of those items. Now if we look in the bin directory, there they are. So let's change directories to bin. Now we can't run any of these files unless they're executable. Okay, so this gets into permissions a little bit. If we look over here, we did ls-al. Over here, there's no X. Right? We can read and we can write. My group can just read, and anybody else can just read this file. But I'm the only one who can write. But I don't have permissions to execute any of these. Okay, so I need to change the mode of the file. Chmod, change mode. Okay, the mode of the file, I need to add execution for hello world.py. And we type ls-al. Now we see we've added the execution bit for everybody. Oops, I'm sorry, it's this one. Execution bit for me, for my group, and for everyone else. So I'm going to add the execution bit for the JS one, and add the execution bit for the bash one. Okay. So these are just text files, and if I just execute one of these files by themselves, like hello world, it doesn't know to use Python to execute this file. Okay, so it's trying to run it as a Z shell script. So I have to make a couple changes. At the very top of my program, I add this comment. So this is the path to the env command, and we're going to look for Python 3. So in every system on Linux, Python 3 could be installed in a different place. env knows where Python 3 is stored. So we look in that directory and find Python 3, and everything after this is going to get executed with Python 3. Save the file, and now I can run hello world.py. I think Python 3. there. So I can execute it with /helloworld.py, and then I might have to load my Z shell run command file again. home.zshrc. So that runs that file that I just created, and that's nice. That's nice to hear. Alright, so now we should be able to run hello world.py. And we can just run it anywhere in the file system. Okay, and we can do the same thing with the JS file. And we have to run this with the node command. Okay, so we have to add, this is called a hash bang, hash exclamation point, the path to the env command, and then what you want this script to execute with. So that's how you can run text files as if they're programs. And we'll do the last one with bash. So the sh file, we want to run that with bash. So we use a hash bang /user/bin/env bash, and then we can run hello world.sh. Alright, and then the last thing to do is C and Rust. So we don't run these text files like in the other three. The other three are just text files. We compile these. So we just have to use GCC to compile C. Hello world.c.bin. And then we're going to say Rust C. We're compiling Rust. That's the RS program. Output it to hello world.rs.binary. Okay. So if I change directories and go back home, I'm not in my bin folder anymore. I'm just in my home directory. I should be able to run hello world.c.bin or hello world.rs.bin. And I can run these commands anywhere now. Alright, so this is a bit advanced, but as we go through things, keep this in mind and come back to this video if you write a program that has a lot of utility for yourself, and you can write your own programs and use them anywhere on the file system. Alright, so that should do it for this video on making your programs commands in Linux.